All right, proceed when ready.
We are the Freiburg Falcons, and we're going to start off with our names. So,
I am Fabian Uribe, and I am at Fry Elementary.
I am Jeremiah Coleman. I am the driver, one of the drivers for the Freiburg Falcons.
I am Christian Coleman, and I am the co-captain of the Freiburg Falcons.
I'm Javier Vita. I'm the captain of Freiburg Falcons, and I'm also an engineer.
I'm Alejandro Fernandez. I'm a 6th grade student at Fry Elementary, and I'm an engineer.
My name is Tomas Hernandez, and I am currently an engineer for Freiburg Falcons.
My name is Matthew. I'm maybe attending Willis, and I'm the tether for the Freiburg Falcons.
I'm Cole Spade. I'm from Fry Elementary, and I'm the alternate driver.
So now we'll start with explaining your robot. So here we have a ROV, other known as Remote Operated Vehicle. So here we have, you guys may be thinking, what's this oddly colored stuff? Well, this is cement glue used to cement these PVC pipes onto the robot so it won't come off so easily. Next, we have these motors, which are 12 volts, I believe, and can push 500 gallons, all three of them equaling 36 and 1,500 gallons. So here we're going to show you how they work. So Fabian,
This is the left forward, so...
It's a turn on.
Okay, so this is the left forward. So, this is the left rev. Just going the opposite way. Same with the right forward. The right rev. And then to go, the lift to go up and down.
that's how control panel looks. As you see,
It's upside down.
it's just, yeah, it's kind of upside down, but just standard. You have some buttons
Switches.
and switches. We have an on and off switch, and we have a battery that's connected to wires. So this big lunk of wire is our 100 gauge
Speaker wire.
100 feet. Yeah, 100 feet speaker wire
And telephone wire.
and telephone wire. So that's mostly it. We use the zip ties to tie the camera and the light. Those are these two.
LED light.
Yeah, LED and color camera to our remote operated vehicle. So hold on. With zip ties, we used epoxy glue, which you can't see because it's clear. Also helped put these in their place so they won't come out. And we used some plastic, so it's watertight. Water can't get in. Next, we have this. We have an arm with two magnets on the bottom for a mission where we have to get an alien. So we're using magnets to get the alien, or we could grab it with our claw. So that's pretty much it for our robot. So
Materials.
on to our materials.
Well, we wired our wires, we soldered them so they wouldn't come off. They're in the water and they're soldered to, like, near the motors, the main vehicle.
And then we covered it with liquid tape to make it waterproof.
That's the red stuff.
And we also use the blue cement, as you see. It's primer on it. Yes.
The robot's made out of PVC pipe. We use 5-inch PVC pipe. We use elbows and T's.
Colored camera and LED light, 12 volt.
We also use 100 gauge speaker wire and tubes.
And then we used liquid tape, and we used a battery to run the control box.
We also use zip ties and motors, so the robot, the ROV, will be able to move in the water.
Motors. No, the motors. They go 500 gallons per hour,
They
and
push
they're
that.
yeah they push 500 gallons per hour, and then they're 12 volts.
Yeah, total. So, the reason we made this cubish shaped ROV is because this was our first year at robotics, and we just went by the book, and it told us to make a design like this. So that's why we made it like this, and we didn't have any revisions. So our mission was to capture. So these people were 9 minutes of the town were missing. So our mission was to capture UFO, broadcast the sound it makes of a boiling energy cell, contact Mulder and Scully. We have to dodge torpedoes as we do our mission, which will make it harder. And we have to capture two aliens. That's what the claw is for, and 2 magnets. And we have to free 20 people. We have to free the 20 people that were missing that one day. So that's our mission.
Also, we encountered some problems with our inventors. One of them, who was formerly helping us, he had to leave, so we were left alone for a couple of days until we had a new mentor who would help us. So we kind of fell behind, but we still managed to make the ROV.
How long were you working on the robot?
Since maybe around January. Before that,
Around
maybe?
January.
This is the first robotics competition for all of you?
Yes.
Anybody had any other experience with robots before? A little bit? What did you guys do?
One time I was in this robots camp when we would build robots out of computer parts and stuff.
Now you mentioned that you had another claw. Where does it go?
Oh, no, that was this claw.
That's that thing, that claw.
Yeah, we have 2.
It's just like a multi-purpose.
Yeah,
Okay.
The airplanes have propellers. How does an airplane differ from your robot?
okay, so
And that's a hard question because you're not building
I think I know, because these propellers aren't as big as the airplanes ones. These are small scale ones. So if we attach these to an airplane, it wouldn't actually fly. It's just because these propellers are a lot smaller, and we have a lot smaller battery to propel it.
And they don't push as much.
Yeah, they don't push as much as huge airplanes.
Also, in the airplane, it's flying in air, and our ROV was sort of made for water. Yeah, swimming in water, so the propellers might be different, the design.
And also, the propellers in an airplane, they were meant to carry the heavy weight of all the passengers in the airplane. So, and also the plane itself, so that it is heavy enough to propel itself up into the air when it gets a strong enough boost.
And how do the propellers in your robot move the robot? What happens? Let's hear from you.
So, to move the robot underwater, well, first it's from wind. So from the wind that the propellers give out, either the wind can push it forward, but if we put it backwards, it moves it back. So that's how they work. Well, since this one's the other reverse, this one's up, vertical. Since if we want the ROV to go up, we push up, and then if we wanted to sink down a little more, since if our object is a little lower than our robot, then we switch it to down.
How do you change the speed of the robot in the water?
It just goes same speed.
That wasn't part of the project to make it go slowly or fast?
That was for the higher group.
Yeah.
For like,
Do you have any thought about how that could happen?
yes, I do.
Yeah,
More volts in the voltage. Like since ours is 12 volt, maybe 24 could probably go double the speed since we're doubling the amount. So
Or maybe the way you like control the switch.
yeah.
Because if you press it all the way, it'd go the normal speed, but maybe if you press like half, it would like slow down.
It would slow down, but still have enough to make it keep going and not just stay
Stop.
right there.
Like a car when you press the pedal, like, depends where you press the pedal at.
So, you guys use an ROV in a box kit, right?
Yes.
How do you customize it to complete the missions? I know you talked about the mission itself in a little bit, but how did you customize it?
Well, we
We didn't customize. We
We
followed
just-
from the manual.
just add on the arm.
Yeah, we just added on the arm to
How do you
complete
customize
the
it?
mission.
Oh,
Oh yeah, by the arm to complete some specific mission, like getting the aliens.
And rescuing
And yeah, and rescuing the 20.
How would you do that?
We-
With the arm, with the claw?
So we would, so there's two different types of alien. There's an alien with a ring around it, so we could grab it with this claw, or for the young kids like us, these magnets, there's an alien with magnets, so when we would go towards the alien, the magnetic force would pull them onto these magnets right here and stick them on, so we could just float back up to the surface and bring them to the surface.
Also for the alien with the ring, if you see, like, we cut little holes right here, and so we have to move forward and get the ring under, and like able to catch the alien.
Because you put it through and you push up so it won't fall.
Yeah, so
Yeah.
it'll just like slide off.
So when you're moving forward, if we just kept this little part here, then the ring would be able to slide off and fall back down, and we would have to go retrieve it. And now since we have this little part, the ring will be stuck, and it can't move. It can just move back and forth, but it can't just fall straight off the ring.
His idea was to cut the notches.
But we would have to be careful with going down, because if we went down too fast, the ring might just go like fly, like wobble off, and then fly off. So we would have to go. We wouldn't have to go that slow. We would just have to be careful when we're going down.
You
So-
guys tested this?
No, we're gonna test it tomorrow.
today.
No,
Today, we're testing it today, right after we get approved to put this in water.
Do you expect that anything, you might need to change some things?
No, not really. I think, well, I think it's fine. It's watertight. We need it has a colored camera so we can see, a light, so if we were in murky water, we would still be able to see something. We still have to add one thing. We still have to add styrofoam right here.
For buoyancy.
Yeah, for buoyancy, so it won't sink. Just
How does
sink.
that, why do you want to be buoyant?
So it wouldn't sink down,
Just like stay like,
So we
So
can
we just like stay at the top or sink to the bottom of the ocean.
We can just have it steady, and we can choose whether it goes up, or whether it goes down, or whether it just stays in the middle on its straight path.
like a submarine.
It could stay like neutral.
We made our claw small because our mentor mentioned that if it were like too long, the weight would push down.
It's
And-
too small.
So we decided to make it like that, and hopefully, I think it would do good. I don't think it would sink the robot too far down.
Have you guys tested the field of vision in the camera?
Yes.
Oh, yes.
So can you see?
Yeah,
Yes.
we
Yes.
just connected a TV to it. We don't have the TV yet.
You can see like